have one more color on the coloring page.
If you do not have the gold sheet, then you can write what we're going to write on paper. Just a second here. So your gold sheet from the beginning of school looked like this. These are all parent functions that we've done before. So starting with linear, quadratic, cubic, then we had absolute value, square root, cube root, exponential. You may have logarithmic blank. Why is it still there? That's okay. Anyway, today's a new one. I don't know why it's still there from last hour, but you can write the new parent function. Our last parent function is 1 over x. Ignore this. It is called the rational function. Some call it the inverse function. I really don't like that name because we know the inverse has a special meaning in math anyway. So I like to call it the rational function. So let's think about what numbers we can put in and what numbers we can't. What can I not have for x? 0. If you want to put 0 in your table and then put like sad face, you can. You could put an x, just make sure you know that it's not an x value there. So there are no values at 0. Let's plug in 1 for x. 1 over 1 is 1. Let's plug in a 2. 1 over 2 is a half. Now that's only 2 points really close to one another. So I'm going to also have you plug in a half. I know normally we don't plug in fractions, but let me show you what happens when you plug in a half. 1 over, we're plugging in a half. Remember, instead of dividing fractions, we keep, change, flip this guy. So what do I get? 2. So that is a pretty nice value. Go ahead and plot those 3 points. 1, 1, 2, 1/2, and 1/2, 2. And if you don't have the gold paper, just write it on your white paper somewhere. Can I plug in negatives? Could I have a -1? Sure, there's no reason you can't divide by a -1. So let's write -1 gives us an output of -1. Let's try plugging in -2 for x. Oh, that gives us an output of -1/2. And let's also plug in -1/2, which again, keep, change to multiplication, and flip. Doesn't really matter if your negative is on top or bottom. Regardless, there is one negative, which gives me -2. Please plot those 3 points then, kind of the same ones as before, just with negatives. And then here's how we connect them. It's almost sort of like a parabola shape, but it's not a U really, but it is curved. It's not a straight corner. Your 6 points do not touch. It is impossible for them to touch because for these 3 to connect with these, they would have to cross over x of 0, and there is no way that that can happen. Okay. Questions on this new function?
Wait.
Yep. 1 over x. So we just plug in 1, 2, plug in a half because that also gives us a whole number.
I just don't like her.
You just don't like
Yeah,
it.
I don't like her.
Okay.
Like a half. It's funny.
All right.
So like every time we graph one of these,
Yeah,
there's gonna be 2 of them.
Yes. But the good thing is they will have the same stretch, like they will look the same. They'll both be stretched the same, shrunk the same, they'll both be moved the same. So it's not like 2 separate graphs really. They will kind of mirror each other.
Are they going to be flipped over in axis?
They could. If
Are they always, will they have to, or does it have to be?
they will always be like in two different, well, I shouldn't say in two different quadrants because it depends on where I move them to, but
Yeah.
they'll always have that sort of shape.
Okay.
They're kind of like opposites of each other. I think after we get through the notes, I think you'll feel more confident with it. Yes, thank you. I had troubles with it last hour. It recorded for 7.5 minutes and then just, I don't know. So the bell work, we'll do it together. Describe, notice it doesn't say graph. Describe, this is in your notes packet, the transformation of the following functions. Wyatt, can you describe, we know the parent function is x squared, this nice little parabola. Wyatt, can you explain what's going to happen to that parabola?
Vertical shrink by a factor of 1/3.
Good, vertical shrink by a factor of 1/3.
And up 6.
Good, and up 6. We could definitely take the time to graph it, but I don't think we need that practice today. Vertical shrink by a factor of 1/3 and up 6. Our next one has a parent function of x cubed. Hopefully we remember what that looks like. If you forget, you can always plug in numbers. That will get you points, and you can plot points. It does look like this, the parent function. Jordan, can you tell me what's going to happen to that parent function?
Reflect over x-axis.
It will. What should we probably do first?
We'll see who's right.
Yeah, I would say, now sometimes order matters, sometimes it doesn't, but I would say do this first. So that's going to be to the right 5. And then we would go out here. So you said reflect over the x-axis. The 2 is vertical stretch. Yep. And then up 3. So I talk about that second, and I talk about that third. For number 1, I've left a space there for a parent function. We've already done that, so we don't really need to redo it, but I am going to plot it. So practice plotting it again, kind of from memory. 1, 1 over 2 up 1/2 over 1/2 up 2. And that same exact thing with negatives.
How do you? I don't know. I have so many questions today.
Well, if you have them, you can ask them, or you could wait, and once we do a couple examples, you might sort of figure out kind of how it works. So we haven't really done too much yet, except for plot points.
I just don't know why there's 2.
Because when you input points, that's what it looks like. Just like when I do this, when I input points, people say, why does he make a U? That's just what happens. That's just what happens when I input a negative. I get 4. When I get input a positive 2, I get positive 4. So it ends up making that shape. It's just when you have that function, that's what the shape ends up looking like. Now, number 2, describe the key features. I'll kind of tell you specifically what I want you to write there. We want to talk about the asymptote. So there is a vertical asymptote. I'll abbreviate. Vertical asymptote. What do you guys think? X equals 0 or Y equals 0? Correct. X equals 0. Because this will be over x is -6, x is -5, x is -4, x is -2, x is -1, x is over 0. There is also a horizontal asymptote at y equals 0, a height of 0. Will there always be 2 asymptotes? Yes. Will they always remain at that spot? No, because if my graph moves up 7, my asymptote is going to move up 7. And you'll see that as we practice it today. Let's look at number 3. How do the graphs of g of x and h of x compare to the parent function? Sketch the parent function and both of them. We will do some of that. We won't do all of that. First, I want to talk about maybe a way to possibly rewrite this. It says 2 over x. For some of you, it may be helpful to write it this way. 2 times 1 over x. Those are definitely the same thing. The top is 2, or 2 times 1, and the bottom is x. But seeing it this way, you're like, oh, here's the parent function. I know what that looks like. And I'm going to vertical stretch by a factor of 2. We're not going to graph that one. We'll graph the next one in this problem. So we are going to graph h of x, which says 5 over x. That's a 5. Again, if it helps you, write it as 5 times 1 over x, which shows you the parent function. We're not adding, not going left, right, up, down. We're vertical stretch by 5. I would like you to plot the parent function. Here we go again. 1, 1, 2, a half, 2. Do some of you have it memorized now? Yeah. Now do the negatives. Jonathan, are you so excited for today?
Yes.
Good. If you would like to connect them, fine. Sometimes I don't connect the parent function if I know I'm going to be moving it around. All right, I'm going to take every height and multiply it by 5. So I'll maybe start right here. This has a height of 2. 2 times 5 is 10. That's off the graph. It didn't move left or right. It just moved the height times 5. Move over to the next point. Current height is 1. 1 times 5, 5. Oh no, we have a fraction. This one has a height of what? 1/2. You can do it. We have to multiply by 5. So that's 5 over 2, which is like what decimal? 2.5. So that point's going to go up to 2.5. And I'll connect those.
So if we figure out one side, aren't they just symmetrical by y equals x, so we can do all the other?
Depending on if it's been moved left or right, maybe not, but they will be like symmetrical.
Yeah.
All right, so go ahead and do that same thing with your negatives. It's going to look a lot like what you just did. Questions on this graph? Has my vertical asymptote changed? No. Has my horizontal asymptote changed?
No.
No. You might think, oh, this is now farther away from 0. It's been stretched, so it might take longer to get close to 0, but it has not been moved up or down. So your asymptotes are the same. Let's take a look at number 4. We have, again, 2 graphs. We'll just do one. Let's say we want to do, actually, I don't think we need to do it. G of x says 1 over 2x. If it helps you, write the number separate from the parent function. We are not going to graph if we can understand what it's going to look like. Do you guys have an idea what it's going to look like? So what we just did, right? Instead of times 5, it's going to be times 1/2 or divide by 2. Okay. Questions on that one? No. Do we need to do that one? Okay. Flip the page. without a calculator, which we're doing all of this without a calculator. Number 5, predict what the graph of negative 1 over x would look like. I would don't tell everybody. I would just draw a really rough sketch of what you think that graph's going to look like.
I got this.
Good.
I just, it's what is the two?
You're stuck on why is there 2 parts?
Yeah. Go away. We don't need two of you. We have one.
Well, there's all kinds of possibilities for x's. So our graph goes in negative 10. If I plug it in, I get a value. Except for 0.
It will never ever touch 0, even if it's like X
Not the
plus 500.
not the parent function, but if I slide it, it might. We'll talk about it. All right, so this is what my function looks like originally. So imagine reflecting this over the x-axis, it's going to be here. Imagine reflecting this part over the x-axis, it's going to be here. So if you guess that, you got it. That is what the graph looks like. Whoa, dear. 6. Where are the horizontal and vertical asymptotes of, let's start with this first one. It says a over x. That's not a number. So I could say 3 over x or 4 over x. Do any of these graphs have different asymptotes from one another?
No.
Right? If I stretch it by 3 or stretch it by 4, the asymptote doesn't move. The graph stretches quicker. Do these have the same asymptote as the parent function?
Yes.
Yes, we've done that. So when they ask you about this one, you should write same as parent function. And those were x equals 0, y equals 0. Vertical stretches by any number does not change an asymptote. This is representing a vertical or horizontal shrink. So like 1 over b, if I shrink it by any number, does that change the asymptote? No. So same answer. Think about the next one. We graph that up here. Do we have the same asymptotes? X equals 0 and y equals 0?
Yeah.
Yes. Same. Does that mean they'll always be the same? No. We have not done the left and right yet. Left and right's pretty quick. Let's look at number 7. Which of these in 7 do you think is going to move left and right? Left or right? A. What do you think is going to happen in B? Up 3. Let's just do A then. Plot the parent function. Is it going to go left or right? Left. Opposite of what you think, just like all of the other parent functions have moved.
Okay, but this, I have a question.
Yes.
So when you move fraction, you move like if I move this, like do I move 1, 2, 3, and it says there
So-
like a whole fraction?
So it's currently here. So 1 is going to be to the middle of that.
Okay.
To the middle of that.
Okay, thank you. There's dots everywhere.
I will want to see you connect the dots where appropriate for your final graph. So don't just leave me a bunch of dots for your graph. Let me go ahead and read the full question in 7. Sketch the graph of each function. Got it done. Describe the transformation. You don't have to write that out. That's just a quick left 3. State the vertical and horizontal asymptote. So you can abbreviate as I did, VA, vertical asymptote. Is my vertical asymptote at 0?
Yes. No.
Where is it at?
Oh, it's at
-3. X equals -3.
Oh, that's right.
Look up here if you would. Do you see why 0 is okay now? You see why -3 is not? That's exactly why. So if your graph isn't perfect and your graph kind of touches -3, I might not take off, but make sure it's accurate with the equation. Horizontal asymptote, it was a height of 0. What is it now?
0.
Still height of 0. So they can move if the graph has been shifted left, right, up, down.
So like for the second one, it would be the horizontal would be.
Yep,
y
up
equals
3.
3.
And your vertical will still remain at 0. Questions? We're going to skip some and hop down to 9B. Directions. Describe each function as a transformation. Identify the x and y intercepts and the asymptotes. Don't worry too much about the x and y intercepts. Start with the graph, and then your asymptotes will only take a couple seconds.
To 9B.
Yep, 9B. You know, if you want some help, the reflecting and moving down kind of gets tricky. Kind of goes above and then back below.
There's too many dots.
It's a lot. Mine helps because mine's color coded. So if you guys want to use colors on yours to color code it with help with all the dots, you can. It's just if you mess up, I'd have to get you a new graph.
What is mine doing? I got one of the sides right there. Yes.
Was it the left side you messed up?
Yeah.
Yep.
Oh wait, never mind. Mine goes that way. How to get up here?
Okay, so this dot is -1. Moves over here. And then when I reflect it, it's going to be right there.
Oh yeah.
And then down 2 more. You probably went up 2.
You go down. Oh yeah. I think
Reflect
I
it, go
did.
down 2.
Ditto.
Jonathan, what do you have for your vertical asymptote?
Vertical, I have x equals -1.
Yes, it is right here. It makes sense that there would be no values at -1, which is why there's an asymptote there. X equals -1. Go ahead with you again. Jonathan, what do you have for the horizontal asymptote?
Y equals -2.
Good, right here. Again, if your graph touches it, which mine kind of barely touches it, I won't take off. Just make sure it's not too sloppy. Make sure your graph doesn't go like up a ton. Which makes sense. Our graph has been moved down 2, so the horizontal asymptote is down 2. Questions on the graph or the asymptotes? X-intercept, Y-intercept. Sometimes it'll be exact, sometimes it won't. So in this case, our Y-intercept has an exact point. That's at -3, or the point 0, -3. Do you guys think we know our X-intercept exactly? Yeah, in this case we do, because there's an exact dot there. That looks like -1.5. That's not a big deal. It's not a huge part of our lesson at all, but I might ask those and you just look at your graph. All right, flip to the next page. If it's okay, I was thinking we had enough practice. I don't think we need to do another one, right?
Yeah.
This is going to do in order what first?
Left to right.
Right to, we do this first, and then we do stretch and shrink. Stretch by a factor of 4. You got to do the up 3 last.
Why did we put it on that side?
Yeah, I know. I figured we wouldn't like
I
that.
don't like that.
I
Yeah.
didn't even notice I can't handle it. I don't know how to do it.
I cannot handle
10 and 11.
and
10. Write a rational function. That's the name of our parent function. This is a rational function. They want you to write one of those that has asymptotes of x equals 5, y equals -8.
We like stretch and shrink in here.
I can't tell you. Can't tell you anything yet.
I'm not doing hard. I don't like this.
Just happened.
I feel like I got this. I didn't even do the X. And it equals 5. This is fine.
Jonathan, we're doing this without a calculator, right? You're just doing something else on your calculator?
Yeah.
He's been cheating this entire year.
Yeah.
It's all gonna lie. Anyway, yeah. A different one.
Okay, Lydia, that makes me think you got 10 done. Are you done with 10?
Yes, I am.
All right, can you tell me what you have?
F of x equals 1 over x minus 5 minus 8.
-5 is down here and 8 is here?
Yes.
Yes, this is going to move it to the right 5. So instead of my graph having an asymptote here, it's going to be moved over 5. Have a vertical asymptote at 5. This is going to move the graph down 8. That's exactly what we want. Now think through 11. It's not as hard as you think.
Crushed it.
James, you have an idea?
Sure.
What do you think?
I put y equals 1 over x minus 7 plus 2 on the outside minus 8. I have no.
Oh, I see what you did. Okay, so you did x minus 7 plus 2 minus 8.
Yeah.
So that actually ends up being the same graph. I like your idea, but that's the same graph. Julian, what was your idea?
2 over x minus 5. And then the whole thing is minus 8.
Yes, so that would create a different graph with the same. So any multiple here would work. Okay, now that we've gone through the notes, now are there more questions? But not like, I don't like this. It's not a question.
Okay, what is because it's just not. I'm not.